Good morning. I'm Dr. Deborah Watson, Innovation Manager at Business West. Business West is a certified B Corp aiming to make the region the best place to live, learn and work. We offer a range of support services and programs to help businesses grow, innovate and export. If you'd like to ask questions on today's webinar, please post them in the Q&A. We'll also be recording the session. Now, when trying to grow and scale your business, time and resources are limited, and the focus is often on the present. This webinar series with AWS looks at future-proofing your business, helping to navigate some of the greatest challenges businesses face today on themes like sustainability and AI. Today, we look at future-fit innovation and data security, a story that is never far away from the news. So what does data security mean today, and what tools can you use to protect your business? With those answers and more, we're delighted to welcome from Amazon Web Services, Solutions Architect Matt Eglin. We'd also later like to introduce Territory Manager Max Barnett. He can't be with us today, but he will speak to any companies that want more information about what AWS do. So welcome to Matt, and good morning to you all. Matt, over to you.
Good morning, and thank you very much, Deborah, for that introduction. And hello, everybody. I am here to talk to you today about data security. And hopefully everybody can see my screen as it stands. Fantastic, thumbs up. And so today, for the next 35 minutes, give or take, I'm going to talk to you about the following. So I want to start at the very beginning. I want to start talking about security, where we've come from, what does that mean today? We will go into cloud security, what this means in the cloud and how we can approach these concepts. Some tools, what we can use. I'll also introduce some frameworks that exist and some open source and other tools and other resources that are available to you out there in the world. So before we get started though, brief introduction about myself. My name is Matt Eglin. I'm a solutions architect at AWS. I've been working at AWS for about the last 1.5 years. Previously, I was at a company called Splunk, doing a lot of work within the security field. I've worked in the industry for about the last 10 years, and I work every day to help businesses to understand their cloud concepts, but also from a security point of view to work on improving and moving forward with the best foot forward in the security space. But before we go into cloud security and the modern way of doing things, I'd really like to go very much back to basics, and really let's go back in a little history. So if we go all the way back in human history, we can see that security and the concept of security was certainly a thing. If we look at antiquity, security wasn't, of course, with our encryption, it wasn't with our data, but indeed our data was still very valuable. We had data in this form of, shall we say, a letter that was secured by handing it to somebody who would take that letter from your city to another city, keeping that information secure and keeping that with them at all times. In a sense, the physical security of that letter and of that information that we had. Fast forward in history a little bit, and we have postage. So of course, instead of entrusting it to a specific individual, we entrusted it to the postal service. We had our letters, we had our information that was kept within letters. We sent that all over the world. And of course, we're getting more and more data, more and more information is being produced, and we're scaling up. Of course, people would, and still do, encrypt their letters. They would put letters into code. We do that very much today. And this ensured an extra layer of protection for that very important and very crucial information that was contained within. Go forward a little bit again, and we have the telephone. Again, a way of connecting information and connecting people together and moving information around the world. Now, increased scale means that we need similar but different concepts and methodologies to secure that information and data that is moving between individuals and indeed between businesses. We would have encryption again, potentially talking in code, but also encryption on the line. We would have secure connections between point A and point B, so we no longer have that runner, that person in between. We can talk directly between individuals, and we are getting additional layers of security and additional layers of assurance to the information that is being transferred between parties. Now, why is this important? This is important because the concepts that I'm talking about here, albeit very ancient in some aspects, are still very relevant today. In the connected world that we have even more information. We have even more scale. We're connecting individuals, businesses together across the globe. We have data flying all over the place. And we also have information that needs to be, of course, distributed, but governed and secured. We want to be knowledgeable and we want to be confident that the information that we are storing, that we are transmitting, is being done in the correct way, and that only those who we want to see that information can gain access to it. So again, we have a concept of physical security. If we think of our modern way of doing things, we have physically secured data centers, so our data is secured physically. We have our encryption. We are writing in code. We have encryption as we send data from point A to point B. We're ensuring that only the people who send it and the people who receive it can understand the information that is held within. And we are also ensuring that we are confident, a la the telephone, that the individual who we're speaking to is indeed, or at least receiving the information, is indeed who they say they are. Now, there are some concepts that we'll explore within this presentation that helps us to ensure that. And so hopefully it will be relevant to you. But first, let us jump into cloud security. So the first thing I want to introduce is something a bit topical. Now, this may look a bit odd, but I asked or prompted a generative AI model, it's called Stable Diffusion, using, I should say, Amazon SageMaker, to give me an image of what cloud security and data security would mean. Now, one of the images it produced is the image you see now on the left here. A very interesting and slightly technical drawing. I mean, I'm not sure quite of the information that's being conveyed here, but what it does, I think, convey is this perception potentially that this is very, very complicated subject. And let's be honest, it can be, but that is why we are here. If we break down the concepts of cloud security and indeed data security, we can find that there are ways to approach security. There are ways of approaching these concepts, which make it simpler, which make it easier to implement and easier to conquer, is the word I was looking for. I also have another image, which is on the right here, which is a slightly different image, which same prompt, same model. But again, this is a slightly, as I would say, Blade Runner-esque image of data security, potentially the vastness of the scale of the problem that we must face. But indeed, we can always say that this is not an insurmountable problem. But I just thought I'd put that in there because generative AI, we're very much shooting forward with generative AI. I believe there is a session on generative AI. I think it's next week, Deborah, correct me if I'm wrong. And this will all be explained on how we can get from a simple prompt of data security to images such as these. But I thought it was a little bit of an interesting output. So why, from a security perspective, are things traditionally challenging? Well, there's a lack of visibility. So if we think about data and information being transferred to different individuals all over the world, there's a lack of visibility as to exactly how that has taken place. Has the information indeed passed directly from person A to person B? Has something happened in between? Do we see how that information and how that data has been handled in transit? There's also a low degree of automation traditionally. Now, again, if we go back to our historical look at things, we have people carrying letters and information between points A and B. As we've evolved in terms of the technology that we're using, we have indeed increased the speed and scale of this, but usually there's a low degree of automation onto how this has been set up. We introduce the risk of human error, and we also introduce a potential lack of governance and audit that could exist in the flow of how we're managing this information and how we're managing this data. Now, as we move into a more technologically focused implementation of things, we can work to resolve these. Our lack of visibility, we can look at intents and we can look at complete audit and logging of the information and indeed the actions that are taking place upon that information. And we can seek to automate tasks as much as possible. Now, by automation, it doesn't mean that it's infallible. Of course, it's not completely perfect. However, what we can ensure is we can ensure a repeatability and a reproducibility of what we are doing. We can have assurance that when we have validated a process, that process can occur again and again in the same way, and therefore with the same levels of security and assurance that we have had before, rather than following, for example, a step-by-step guide. This is certainly something that when I started in the industry, I was doing all the time, and I'm sure it still happens, but you would follow usually a Word document step by step to actually complete a task. What we want to do now is we want to automate those functions, automate those processes so that we can avoid the human error and indeed the copy-paste errors that may or may not occur during processes. From a cloud perspective, we must look at this from a much larger holistic view. Now, we have on the bottom here, you can see we have different processes that we must follow within our security and on our security response. We have the identify, protect, detect, respond, and recover. So from a security perspective, these are 4 different stages that we must face any threats, and also stages which we must face any vulnerabilities that may exist within our security and within our data and information flow. You'll see here that different aspects such as IT operations management, network protection, threat detection exist in more than one of these different areas. Now, there can be, the reason for this is that there may be different services, different technologies, and different platforms that exist to help to either identify, protect, detect, or respond to something that has occurred. The point being is that we cannot think of things as, we cannot think of services, software, and approaches to just one of these. We cannot say, oh, all we're doing is protecting. Okay, but if we're just protecting, we've missed a step. We haven't identified what we need to protect. If we're protecting, we must also have the ability to detect when that protection may have not worked as well as we wanted. And of course, we must always be able to respond and recover in the event that something has happened, a detection event has occurred, and our protection has not been what we wanted. Something we say in Amazon and AWS is a saying from our CTO, which is everything fails all the time. Now, this isn't supposed to be a saying of doom and gloom, but what we must do is we never assume that everything will just always work perfectly. We must always prepare for things to occur in a way we have not expected. And this is still very true and is probably especially true from a security point of view. So these 4 layers, identify, protect, detect, respond, and recover, are ways of starting to break down how we actually approach these different threats, these different vulnerabilities that may exist, and also how we can start to contextualize what we are trying to accomplish. One thing I must mention as we're talking about the cloud, and as we are AWS, I must mention the shared responsibility model that exists. So within AWS, we are responsible for the security of the cloud. Now, this is things like the data centers. So back to our analogy of our physical security and protection, the data centers, the platform that exists to operate your applications, to operate your business, we will provide the security of the cloud. Now, the security in the cloud is the customer's responsibilities. That is the people who are running operations and applications in the cloud. There is still a level of responsibility for you and for customers in AWS to secure what they have in the cloud. Now, we will provide that strong foundation, but there is still a responsibility on the customer. And the reason I bring this up is that I don't want to say that you put something on the cloud, it is perfectly secure. No, we must always be conscious of the fact that there is a responsibility to ensure that what you are doing is secure and that we're approaching it in the best possible way. Some advantages, though, I have to say is that when we're running in, for example, a cloud provider, we can inherit global security and compliance controls. Now, this is just a sample of what, for example, if we were running in AWS, what we could inherit. And the reason I also want to highlight standards is that they are a way of assuring that what you are using, and it doesn't have to be AWS, it could be a software package, is indeed as secure and compliant as it claims to be. Now, the compliance standards, I will pull out one here, which is ISO 27001, which is a standard which ensures that that, for example, the quality and the assurance given and the security of a piece of software and organization is indeed rigorous to comply with the standards set in this set of standards. Now, there are different standards all over the world. For example, there's some from the US here, Japan, Germany, the UK as well. It is a way of validating, indeed, them being assured that there is a level of security and a level of reliability on a service that is not just assured by a third party. And I think that's the key point, is that it's third party assurance as to what you are using. Now, I always must mention also the continuous improvement lifecycle, because if we have our approach and if we have our way of tackling the threats that exist to our business, or indeed the vulnerabilities, or indeed the risks, we must follow a continuous improvement lifecycle for these. We must always be learning, measuring, identifying, prioritizing, improving, and sharing the results of that in order to ensure that the approach we are having is optimal. Now, at AWS and at Amazon, we always like a good mechanism, or indeed a good flywheel, hence the circular motion of the diagram you see here. And what we want to ensure is that, especially from a security point of view, we must always be feeding back into our assumptions and feeding back into our approaches as we move forward. Security and indeed the general technological landscape is something that is changing very, very rapidly. It always has done, and indeed it is changing even more quickly as we move forward into the future. So we cannot ever assume that what we did, for example, yesterday, we made everything secure and we have good compliance controls, we have good governance. Is that still the same today? And will it be the same tomorrow? We must constantly be reevaluating. We must constantly trying to prioritize and improve what we are doing, and share that both within our business. And I would always encourage, if you have a good idea, share it outside, because you will get third party opinion, you'll get other opinion and information coming back to you. And with the sharing, we can push this into other workloads. If we have some good ideas, indeed, it may be able to be used elsewhere. And we can use again those learnings back into our original flywheel. We can continuously evolve and we can continuously improve what we have. We talk about it. So I talked about a few things and approaches. To talk about something a bit more technical as an approach, I want to mention encryption. Encryption is something that is complicated, shall we say. I'm not going to go into a deep explanation of what encryption is, but what I want to make everyone aware of is that it can be used by everyone. Now, with encryption, we have to always consider one thing, which is the data. What are we trying to protect? Now, when we're protecting our data, we want to ask the question of who are we protecting it from? Are we protecting it from someone outside of our organization? Are we trying to protect it from inside our organization? Do we have specific compliance for that data? For example, maybe it's customer data. Do we want to ensure that that data is only accessible by by the people who need to access that data for a specific purpose? So always consider that, excuse me, with your data. With encryption, we have the data. We also will have a key which gains access to that data. Now, the key is something that I would say is, well, it is very, very important. It will grant access to the encrypted data. It should be secured, and it should be, again, only accessible to those who need access to it. What I would say from experience, I would encourage people not to accidentally upload this into a GitHub or code repository. I have seen that done. Protect your keys as you would protect the keys to your house, because they will grant access or indeed open the door to your data. So normally, I think from an encryption point of view, these are two things that are considered, but there's a third option here, or third item, that is less considered, which is the algorithm that's been used to encrypt your data. And now you may ask, why is that especially important? Well, the reason being is that we may have a very strong key, we may have secured our data. However, algorithms wane over time. The algorithms that we used to encrypt data 10 or 20 years ago are not considered industry standard practice now. And while we can consider the algorithms that we have today to be strong, we must, again, if we think about that flywheel and reconsidering what we have, we must continuously look at what are we doing? Is the algorithm we're using still secure? Is it still considered good practice? Do we need to update our processes? Do we need to improve our security by choosing a newer algorithm? Now, I wouldn't say do this every single day or even every single week, but it's something to bear in mind from that continuous refresh and continuous consideration. Consider how you're encrypting your data. Do you need to maybe make a small change to ensure that the long-term future of that encrypted data is secure? So 3 things to always consider with encryption: data, what are we protecting and who from? The key, where is the key? Always be sure where your key is, and the algorithm that you're using to encrypt that data. Coming off the back of that, where I talked about keys and I also talked about need to know in terms of granting access to data, I want to make a strong case, or try and make a strong case, for credential management, mostly because I have seen this go wrong in a previous life. You should always have assigned credentials. Now, it's very, very common to have, for example, service accounts and access keys that are granted to usually engineers or support personnel in order to access devices, to access services, to perform activities such as deployments, such as support. Now, this is still very valid. However, I would encourage you to look at using assigned credentials to ensure that those credentials are granted specifically to users so that we have that auditability. If you remember, we talked about being able to audit and trace and govern our data and our access. Ensure that we have assigned credentials so that we can do that. And we're not just looking at service accounts. Automation can help to ensure that we remove that human error component, that we don't actually need to grant access to machines and to services. We just need to grant access to run specific scripting, which we've already checked is going to do what we know it's going to do, what we want it to do, excuse me. And we also then encourage a least privilege approach. We don't need to give people access to production machines or indeed production databases, because we have moved that access into a layer of automation, a layer of assigned credentials. So we keep people and we keep access away from the sensitive data that we may hold. I would also say short-term credentials, always be encouraging refreshes of the credentials that are granted to users. When we're granting access keys, consider, are we granting for 1 day, 30 days, 60 days, 1 year? What if that key was accidentally mislaid? We want to ensure short-term credentials so that we can be confident that should something happen to the keys and the credentials that we are issuing, that there is a short-term usage of those credentials, and indeed the problems that could occur from that are minimal. So moving along a little bit to some patterns and concepts, I want to talk about risk, because risk is something that is a way of starting to consider what is your security posture. Now, from my experience, risk is something that I see a lot of businesses driven by compliance requirements. There's a risk and compliance requirement in order to mitigate your risk. This is sometimes quite nebulous in a concept. Sometimes within compliance, this is very well defined on what your risk should be. But I would encourage, from experience working with customers and businesses on establishing their security posture, I would encourage you to start with a risk profile. Now, your risk must be understood, and it also allows you to prioritize, because we only have so many people in our business, we only have so many hours that we can work to secure and indeed push this forward. We must prioritize on the risks that we see would be, for example, high impact and maybe high probability. Now, the way in which we can do this is we have our low impact, low probability risks. They're a risk. It's a risk. If it was to occur, the impact is low. It's highly unlikely to occur. Therefore, we can deprioritize this within our business. As we move forward, we come to our higher impact, higher probability risks. We must spend more time and effort to mitigate those. And indeed, as we go further and further, we have higher impact and indeed critically impactful things that may occur, or indeed risks that are very, very important to our business. So if we're talking high risk, we may start be looking at, depending on your business, we may now be including things like payment information from customers, things that if there was to be an issue with this would have a very, very high impact. Granted, it's a low priority, but we want to ensure that a proper time and attention is given to this risk, and we develop methods and we ensure that the process is secured. Now, what I would also say from experience is that this is something that you can try and do it generically, but you should always look at your own business and your own business's needs and risks in order to generate your risk compliance, because every business is different. There are great frameworks that can be used, and indeed there is a lot of work that's been done to measure risk and indeed risk and probability, which you can reuse, but always look at it again with a layer of your business over the top of it, and consider what would be a high impact, high probability, or indeed a high impact but low probability, but we still want to spend significant time on that, for example. And with that, we have governance rules. So if we have high impact, well, do we want to be proactive or detective? Now, this is very, very important in these two areas. With detective, with governance, we want to be able to identify issues, highlight them, and maybe take action on them. Now, this is take action on something that has occurred. With our risks, if we have identified things that, for example, low impact, maybe low priority, or maybe medium priority, we ask ourselves, is a detective rule sufficient? Do we want to be alerted when something's happened? Maybe it was actually legitimate. It was a false positive, for example. We don't want to block something because maybe that it would impact our business and our customer flow. We want to highlight it, we want to track it, but we don't necessarily want to be proactive, where we would be preventative. We would be specifically blocking, denying, or preventing actions from taking place because we would consider them to be high risk or indeed high impact. A good example from my experience of this is, from an AWS perspective, is if you make an S3 bucket publicly available, so anyone can access the contents of that data storage bucket. This is something we would want to be proactive, and indeed we do this within AWS. We block access publicly to these buckets because we would consider this to be a high impact risk to the business. So this is something, I mean, if you're using AWS, we have AWS config that can be utilized to enact these governance rules within your deployment. And you have a choice. There's a load of rules that are built in, but you can make your own, and they can be detective, as I say, or indeed proactive, depending on the risk that you've identified. Briefly mention something called the data platform. Now, the reason I mention this is something I have seen implemented in many businesses throughout my career so far, which is trying to build a data platform surrounding your security information. So I talked about audit and governance. I talked about having credential management. I talked about being able to track what has happened and the flow in which we have our data through our business. If we look at building a data platform, or indeed having a single point of truth in order to understand and to understand and to analyze that data and that information, we can start to try and put context to it. So, for example, what I've seen done in the past is storing all of your logs, your audit, within a centralized lake, and using something like OpenSearch, indeed in this example, the Amazon OpenSearch service, in order to query that information if we were to look for any specific activities that may have taken place, also to understand what has occurred, if indeed something has occurred. If we can then do audit, we can trace back, we can understand what has happened, and then we go back to our firewall. We can learn from that, we can enact, we can prioritize, and we can make changes to ensure that we have secured what we maybe did not secure quite so well previously. And because AI is very much a topic du jour at the moment, I have to say that once we have our data lake, we have the option of utilizing things like AI on top of it. Now, how might this be useful, you say? When we have large quantities of data, and I would say that we're looking not necessarily on the left of this image, but on the right of this image with what we call foundation models. I won't explain what they are. You'll have to come back next time to learn more about what foundational models mean. But the big thing I want to focus on is that a foundational model can take in unlabeled data, analyze it, and do things like summarization and information extraction. Why might this be useful in a security context? Well, if we have our data, we have our information that's been stored within this lake, we can, instead of having to spend hours potentially crawling through that information to find something, we can ask our foundational model to summarize, for example, many, many gigabytes of data. So we can start using AI, we can use foundational models, as we call them, to analyze this data on our behalf and to give us information about what has occurred in a much faster time than we could if we analyzed it manually. Also, if we go back to automation, there's potentially less chance of something being missed, as our model can analyze terabytes of data or indeed gigabytes of data in order to give us that output. So very, very useful, potentially very, very useful. I will say it's very much in early stages, but we do see it as a way of helping us along that security journey. I also want to introduce a concept as well called shift left. So this is something that has existed in the development DevOps community for a while. And the idea being that, and it's not just in security, but with a security slant, is that we move the application of security to the left in our development pipeline. As we're developing software and applications, traditionally, we go from a design phase. We design what we want, we get requirements, we understand how we're going to do it. We build that, we have our engineers, we build that, we test it, we deploy it. At the end of that, at least in my experience, we throw that application over to the security team and say, can you make this secure, please? We need it. And then we deploy it out into the world. Now, this makes it challenging from the security team because they now have to put a security wrapper around a application or indeed a concept. What we would suggest, or at least what shift left suggests, is that we move that security to the architecting phase. We shift left along the development pipeline. We want to be secure by design. So we want to challenge these concepts. We want to look at our security concepts, our governance, how are we going to govern our access rules, how are we managing our data, how are we managing our application at that design phase, rather than at a point of throwing it to the security team and asking them to take a look. Now, this is becoming more and more common, and I do see this happening within the industries where we are looking at not just security, but things like operational ability and support very much at that design and implement and requirements gathering phase before we've done the implementation. This does change the traditional way of doing software development in our life cycle, but it does produce better results because we do build these things in at the start. Or at least they're designed in from the start. A tool that is also available to you is the AWS well-architected framework. Now, the AWS well-architected framework is a combination of multiple pillars, one of which is security. And these pillars in the framework are here to help you to build reliable, secure, operationally efficient workloads. And these, the frameworks can be applied, to be honest, they can be applied to almost any piece of software development work. It doesn't necessarily have to be within AWS. The concepts that are made available through the well-architected framework, I would argue, are valid in any software development lifecycle. And what we can utilize is we can utilize the well-architected tool in order to reflect on what we are doing and to improve how we are implementing. So we can use this to generate reporting, which can indicate potentially where our priorities should be, similar to what we have looked at with our risk framework. We can also leverage our risk framework within the well-architected tool to give us priority on what we should be focusing on. And the well-architected tool gives us that guidance to understand where we should be focusing our time and how we can move forward in a sensible way. We can also then track how we have done using the well-architected tool. We can track that we have actually indeed moved things forward, and we have reflected, and we have improved our posture. And as I say, not just necessarily security, maybe reliability and some cost optimization and performance efficiency in there as well. Zero trust is also something that I think is worth mentioning. It's very much a very hot topic at the moment in the security fields, but I must be clear that it's not there's a misconception with zero trust, is that it is a software tool, or B, a button that you can turn on to say, I now have zero trust, I now have a zero trust model, I've implemented that. It's not that. It is a conceptual security model. So it is made up of multiple different things, usually multiple different components of your infrastructure, in order to have a posture whereby you don't specifically, for example, trust a network segment. You're not necessarily even trusting a user just by the fact that they're the user. You're constantly challenging maybe the incoming traffic, network traffic. You're constantly challenging the user to prove that they not necessarily they are who they say they are, but they have permissions to do what they want to do. The action that they are undertaking is allowed, and we constantly challenge that. Now, the advantage of that is that we can break down these traditional silos and network boundaries, whereby we can avoid the how to find a good word, the pain of having to log into a VPN in order to access a business tool. Now, this is usually a nightmare if you're traveling frequently. Certainly, something I found in the past, that the VPN doesn't always work, and we can't access that critical business tool. If we're constantly challenging using multiple factors, not just, for example, the network that you're connected to, we can make these tools available over the internet, and with, of course, with still substantial security controls in place, but we make it easier for our workforce, and indeed easier for our users to gain access to the tools that they need to do their business. So zero trust, I would highly recommend reading more about it. I'd love to tell you more, but we've only got limited time, but very, very, very important topic. Just to talk about some frameworks that are available for you. There's the Open Cybersecurity Schema Framework, which is a relatively, actually not so new anymore, framework that's being, that's Amazon, AWS, as well as many, many other companies are collaborating on in order to provide a consistent way of classifying and also analyzing security data. This is something that can be leveraged in Amazon Security Lake if you're using it, but also it is a new industry standard that I feel with more and more companies that are signing up to it, we will see there'll be a unified way of analyzing and indeed classifying security log data. There's also the MITRE. I also want to mention the MITRE ATT&CK framework, which is a way you can classify. So this is a very frequently and commonly used framework in order to classify threats and to classify the types of threats that are occurring from well, not necessarily an internet point of view, but from a technological point of view. Why is this important? It's important because when we are analyzing our risk profile and we're analyzing what we are trying to achieve, we need to do it in a consistent way. And we need a way of classifying risks, threats, and vulnerabilities in a way that makes sense across different teams, but can also help us to learn from what may have occurred elsewhere. And MITRE ATT&CK framework is a great way of doing that. I would also like to mention the Open Worldwide Application Security Project, or OWASP. They are a community-driven organization which produces a lot of good content freely and open source, which is based around security, protecting yourself, protecting your data, but also interesting analysis of existing trends within the industry. They also do, or what is also created through OWASP is the JUICE. I'm going to remember the name now. The JUICE bar project. I think I've got that wrong, but it's something I have used. It's quite a cool application that you can download, you can install, but it acts as a gamified way of analyzing security vulnerabilities. And bills itself as the most insecure web application that you can download, but there's a good reason for that. It's because you can use it to analyze, you can use it to test out tools, test out techniques on a known vulnerable problematic web application. So it can be a great educational tool, and it's a great way to learn a little bit more about how things can get insecure by implementing it and using it. So I've talked a lot in the last 20, 30 minutes, and it's a lot of different things that I've introduced, and hopefully it's given you an idea of some of the approaches that you can take to cybersecurity and indeed data security as well. Just some next steps that I can highlight. There's always training and certification available within AWS. The training and certification, if you go to the web address, I've got a QR code link to make it a little bit easier in a moment. But there are many ways of learning, not just about security on AWS, but there's also conceptual understanding of security. Things like zero trust, things like protecting your credentials, encryption, etc. Speaking of QR codes, the one I just mentioned, so security training is on the left here, but also the AWS security blog is on the right. So this is where we publish our latest white papers, our blogs, information about security topics, securing on AWS, but also building robust, secure infrastructures as well. And finally, I would like to say thank you. Thank you for listening. Hopefully it was useful. Please, if you'd like to connect with me on LinkedIn, I'm always happy to talk AWS, security, compliance, or indeed talk about T. So thank you very much. Any questions?
Wow. Thank you, Matt. We have got a few little questions popping into the chat. The very first one I will answer, which was, will the slides be shared? Yes, they will, and we've recorded the session too, and the recording will be shared. So that was just for everybody. So the first question's appearing in the chat. Do you use quantum secure encryption at AWS?
So that is a very good question. There is a project that we currently are undergoing in order to research quantum security. Now, I think it's still in relatively early stages. We also need to look at, when you say we're using it, I would ask for clarification on where you ask when you say where we're using it. Is it something that you want available for you as the customer, or indeed within the foundation that we provide? But it is something I would say that we are. There's ongoing research into quantum cryptography and quantum security. It's still in early stages. However, I would say that keep an eye out on the security blog, and keep an eye out for reInvent that's coming up. I think at the end of this month, we're already in November, for new announcements on quantum security, quantum cryptography even.
Lovely. It's fascinating how that's coming along. Next question is sort of related, which is, what are you doing with blockchain?
Many things. So blockchain is certainly something that we make available as a service. So from an AWS perspective, we do have the ability to run your own blockchain, or indeed utilize a managed blockchain service. So indeed, if you're looking for a blockchain solution, so that could be, of course, for tracking assets, it could be for ensuring that you have the ability to validate a certificate, or validate a piece of data, or indeed an image is the original, or indeed is what it says it is. There are services that are available to help you there.
Next question I've got. The companies you work with, particularly the small ones, do they tend to be more sort of reactive and come to you when something's happened, or more proactive nowadays in terms of trying to put things in place in advance of something happening?
That's a very good question. In my personal experience, it's a bit of both. Certainly, there is a desire to move quickly, absolutely, and that can encourage a reactive mindset. Now, that's not necessarily a bad thing. If we remember our risk profiles, if we've got our risk profile right, then that can work. But I would always encourage you to step back slightly and look at shifting left and moving that design to a more detective approach. But it is honestly, it is a bit of both. I can't say it's one or more.
It's a bit like when people install the security cameras and burglar alarm after they've had a break-in, rather than doing it beforehand. So try to get people to do it in up front. One of the things we're aware of from a Business West perspective, which I thought was interesting with your continuous improvement life cycle, we're trying to get more businesses to actually step onto the cycle. Part of the purpose of the Future Fit series is to get people to think about this stuff rather than just carry on the day-to-day, because if you're not on the cycle, you're not even looking. So I thought, in terms of your security in cloud, again, identifying what you need to be doing and protecting is absolutely key to just starting this process. So we're trying to encourage the companies we work with at Business West to start the process of thinking about their security. And one of the things we also encourage is we work quite closely with the Southwest Cyber Resilience Centre, who have a 10-point plan for people just to start. And that helps move them towards cyber essentials. And I think for a lot of us very small businesses, just getting started, so you understand, would be where we'd encourage them. And then once they understand a little bit more, actually coming to AWS and starting to get some of your tools in place to take them to the next level strikes me as a really good route for people to take. So just get started rather than keep your head in the sand, because I think the message we're receiving is security is something that everybody needs to have in place. It's not something where you can put your head in the sand and just think it won't happen to me. The chances are nowadays it will, so you need to be prepared. And on that note, the next question is coming in. So how do some of the small businesses you work with approach this? How do you start? If I was a small business and I came to you, where do you start? What do you do with them?
So it's comes back to looking at that risk modeling. Also, we start with asking the questions, well, what are we trying to protect? And that's coupled with what are our risks? And what I would normally do is sort of spend, take a good amount of time, let's not rush it, half a day, with a very large whiteboard and lots of colored pens. And let's just draw out what are our risks? What are we trying to protect? What are our business objectives when it comes to what are our business objectives, and how do the risks that we've identified fit in with those? Therefore, what can we do to protect? We look at that detective, or do we need to be detective? Do we need to be proactive? That usually comes in the fact that we've identified critical, high priority risks, or indeed areas which are maybe no-goes for our business, where we definitely can't afford for this to happen, or we do not want X or Y, or indeed other areas where we'd like to know if it was to occur, but we don't have the resources to invest much substantial time. And I think that one is something that, to be honest, it's something I find it's not necessarily just small businesses. It's being able to prioritize your time so that we can be focused on what truly matters. Because if you lay it all out on the big whiteboard, there will be a lot of things, but this is why we need to go into that prioritization and that risk understanding mindset so that we can focus our time on the most important areas. Lovely. And that's a great place to start. It will give you direction. It certainly will give you lots of directions to go in.
Absolutely. And our key message is do start. That's it from questions that are coming in. So if you've got another question, you've got like a minute to put it in while I say other things. I did introduce Max earlier as territory manager, and we weren't expecting him to be on call today, but I have noticed he's appeared. Max, if you are still travelling, stay off camera and don't join us. But if you are available, you can pop in and say hello to people. So in terms of where we are next, in terms of support available, the AWS environment, obviously, and a technical security review is available to anybody that wishes to follow up on this webinar. So that's the key bits for you to come to us at innovation@businesswest.co.uk, and we will link you up with Max, Matt and the team at AWS. So a great big thank you to Matt for today's session. That was fascinating. I have to admit, I love the acronyms, and I think my favourite today was OWASP. But to understand what all of this means, I think you need the technical security review and the team at AWS to walk you through some of that. So thank you to Matt. And alongside the further opportunities with AWS, Business West also offer a range of support services and programs to help your businesses grow and innovate. So if you are interested, do get in touch via the email address on the screen to find out more. Then if you'd like to join Business West and AWS for the last of the Future Fit series next week and learn how to safeguard your business and on the potential for exponential growth, next week's topic is a topic of the moment, which is AI. So in this session, we'll be asking why business owners you should get on board and along with the benefits of it for your company and employees. So finally, a big thank you to our guest Matt today, and a thank you to you for joining us here at Business West. Have a great day.